Welcome to AccelerateX, everyone. In the past few months, we have built a wonderful suite of Databricks accelerators. In this series, we are going to cover how these accelerators are helping solve complex enterprise data challenges. I am joined today with our SME, Jafar Kaushal. Jafar, warm welcome to the series.
Thank you.
Let's start with the first one today, DQPulse.
DQPulse is our metadata-driven data quality frameworks. And as you know, data quality is something when you build your data intelligence platform rather. So DQPulse is something which is inevitable, where to get the confidence in a data, you have to implement this data quality. And that's where our DQPulse framework come into picture, where it automate all your data quality things.
And oftentimes it's one of the biggest friction point in companies with thousands of critical data elements and huge amount of rules to be applied. How did you guys think of this particular accelerator? What's the background of it?
From hundreds of source systems, 1,000 plus CDE field, practically it is not possible to sit and write all the rules. And that's where we thought of making our DQ frameworks metadata driven. So now you just go feed the metadata information into our config table, and all the libraries of DQ are enriched, where it can configure automatically, and all the data quality checks apply on CD, non-CD fields. 90% of roles are get matched. 10 and 20% you basically the business rule specifically, not the technical rule. There we append or add in our library if something comes out of the box, so that we add.
Databricks already has declarative pipelines and numerous other tools, right? Why this particular thing, DQPulse?
Whenever you go for doing some complex type of check, let's say cross-domain, cross-function, that time you see the difficulties by leveraging the native feature. And that's where this DQPulse stand out. It gives you a flexibility to enrich your rules.
Inline dependencies like city and a pin code or a zip code, and then
Correct.
cross data field relationships like parent and reference data.
Correct.
So both those, that's very powerful indeed.
Yeah.
How do you guys handle the real-time inline data quality check and make sure that it does not impose undue amount of processing latency, or even some would call SLA breaches or OLA breaches?
Yeah, part one is whatever the libraries I was talking about, that has been defined, written by the developer by following all the best practices, the standards, making sure our code is efficient. That's the first part. Second part is when we are integrating it into the frameworks, that we make sure that all the rules runs in a parallel. It's a metadata driven engine, so only the required rule get scanned and it get executed. So all this considering in a box, our framework runs scalable, it's highly efficient.
Now let's look at the future a little bit. GenAI and Agentic AI. What happens to those AI agents which depend upon good quality data once the DQPulse comes into the picture?
Everything depends on what quality of data you are feeding, right?
A sense of scale on which DQPulse was deployed. What was the number of feeds, the data sets, the number of business rules, and the time frame in which this was deployed to configure it?
Where we deployed this was 100 plus source systems, and there were 10,000 plus CDE field, critical data element field. So where we apply this DQPulse, and as I said, in the incremental we were getting hundreds of GB of data per day. So that kind of a scale we have seen and tested our frameworks, and it works smoothly, I mean, with no significant performance impact and all.
Excellent environment, right? With Azure or with GCP or with Amazon, or custom integration, right? Is DQPulse heavy lift to integrate? What is the time to go live with DQPulse?
Let's say it can very easily integrate with the notebooks. It is just a library we have to include, and it get integrated with the rest of the pipeline. So I would say no, it's the integration is not complex. It's as simple as writing the second piece of code.
I appreciate everybody who joined today. We'll be coming up with more episodes of our accelerators as we go ahead. Thank you so much, everyone. Thank you, Jafar.
Thank you.
Really appreciate it. Thank you so much.